Today we will start the next exercise, that is 5.7 of NCERT of class 12th, that is second derivative. That is, the topic is find the double derivative. And in case we have been given a function and it is being asked differentiate the second derivative, differentiate it 2 times or find the second derivative, so how to find it? Let us now see the first question of this exercise. I first of all will solve it. The question is x square plus 3x, x square plus 3x plus 2. Now it is being given, find the second order derivative of this function. Find the second order derivative of this function x square plus 3x plus 2. First of all, I will let it be y. Let it equal to y. Now I would differentiate it. That is dy upon dx, and that is equal to, what is that is equal to? Our ddx of x square plus 3, our ddx of x plus ddx of 2. That gives us, you may write down the 2 here or you may write down here and 1, doesn't make same thing. So x square derivative 2x and x1 or 1 or 2 constant, that is 0. So this is our first derivative. It is also sometimes written as y1. y1 means first derivative. 1 stand means first derivative. It is also sometimes written as y dash. Single dash means first derivative, first derivative, first derivative. And what is the symbol for the second derivative? I just tell you right here, before doing the second derivative, symbol for the second derivative is d2y dx square or y2 or y double dash. So these 3 symbols are being used for finding the second derivative. Of course, we will be using the dy upon dx. So if I use this one, then what is the second derivative? d2y upon dx2. That is equal to, now what is the derivative of x1? The answer is 2 and derivative of 3 is 0. So this is our second derivative. So this is the second derivative of the given function x square plus 3x plus 2. First of all, I let it equal to y. Then I differentiate it dy upon dx. After differentiating here dy upon dx, I differentiate it again. So second derivative d2y dx2 2 is the answer. So this is how to find the second derivative. Now I go for the next question of this exercise, and that is your question number 3. Next important question is question number 3, third question of exercise 5.7. Let y is equal to x cos x, x cos x. Again, we have to find out second order derivative of this function. Second order derivative of this function, we are supposed to find it out. Now, how to solve this question? Again, I will differentiate it 2 times. It is a product rule. One of the algebraic function and another is trigonometric function. It is a product of 2 functions. One of them is algebraic and another is trigonometric function. So product rule we will be using. You might recall, what is the product rule? It is equal to dy upon dx u into ddx of v or plus v into ddx of u. And in case we have got the 2 functions, y is equal to say u into v, and we have to differentiate product of two functions. It is a product of two functions. So how to differentiate the product of two functions? That is, first of all, write down any of the function into derivative of second, then plus here which has been differentiated. Now write it as such, the original function v here, and along with that differentiate the other one. It is simple, v here and d dx u. This is your u here, the d dx of v. This is the, now accordingly I will do dy upon dx, that gives us x into cos x का derivative is minus sin x plus our cos x as it is, or derivative of x would be 1. Now this is the first differentiation. It is the first differentiation. What is this one? X and bracket minus sin x, cos x derivative minus sin x. This is I have taken the u, this I have taken v, u as it is, derivative of v plus v, derivative of x1. Now this is the first derivative, that is minus x sin x plus cos x. For second derivative, again the product rule has to be used and the symbol to be used d2y dx2. So it is minus product of two function x sin x, and that gives us x into cos x plus sin x as it is, derivative of x is 1, and plus cos x, that is minus sin x. So this is what is being the second derivative. It is a second derivative. Now in case I clear the brackets or take this one, or I take the this also within this bracket, I take out the minus common right from here also, so then it would become minus x cos x, this will become plus sin x will get 2 sin x. So this is our second derivative, that is minus x cos x plus 2 sin x. That is the second derivative of the question number 3rd of our NCERT. Product of two function was given and we have to find the second order derivative. We have to find second order derivative. Now after this I go to some other important questions, and that you can say, let us go to the question number 8. Question number 8, that is y is equal to tan inverse x. Now we are supposed to differentiate second, we are supposed to find the second derivative of the function tan inverse x. So first of all I say let y is equal to tan inverse x, then I will differentiate it first time dy upon dx, and what is the derivative of tan inverse x? That is 1 upon 1 plus x square. Now this is your first derivative, but we have to find the second order derivative. So what I do like this, say 1 plus x square raised to power minus 1. This can be written as like this also. It doesn't make any difference. It has been taken to numerator with the negative sign. Now it is easy to differentiate second time d2y dx square, and that is equal to minus 1 plus x square to power minus 2, and according to chain rule, one derivative of 1 plus x square, that we get the 2x. So overall answer comes to be minus 2x divided by 1 plus x square ki power 2. So this is our second derivative of tan inverse x. So similarly, we can find the second order derivative of all other trigonometric functions. Tan inverse x, other function is our sin inverse x, cos inverse x or cot inverse x, and apart from that secant inverse x, cosecant inverse x. So as we have done the derivative of the derivative of the tan inverse x, similarly we can find out the second derivative of all of the remaining 5 inverse functions. These are the remaining 5 inverse functions, and we can find out the second order derivative of all these of the 5 functions, just like this way as we have done. The same, this is a method for finding the derivative of other 5 inverse functions, trigonometric functions. Now let us go to the next important question. After doing the question number 8, let us go for next important question of this exercise, that is your question number 10. Question number 10. Y is equal to sine log x. So we have y is equal to sine log x. It is not a product of two functions. It is sine of log x. It is a sine of log x. So now, how to differentiate? First of all, first time dy upon dx, that is the first derivative I mean to say, that is dy upon dx, sine ka derivative over cos log x into derivative of log x by chain rule method. By chain rule, देखो sine log x, we got cos log x. Now we have to differentiate the log x also by chain rule method. Because of chain rule method, derivative of log x is 1 by x. So this first derivative we are getting here cos of log x divided by x. That is your first derivative. But we are supposed to find the second derivative. Now here it comes to be a quotient rule. Now we will be using the quotient rule. It is the division of the two functions. So that we apply quotient rule as you have done ddx of u upon v. This rule we apply and we get second derivative as, write down this x as it is, into derivative of ddx of cos log x minus cos log x into derivative of x, ddx of x, and divided by square of the denominator, that is x square. So this is how we are able to find the second derivative, and that is cos log x upon x, x ddx of cos log x numerator minus cos log x as it is into derivative of x and divided by x square. So this is a formula of the quotient rule, u upon v. In the 11th or earlier classes you must have done it. Alright. Now we can simplify it. So what is the derivative of cos log x? X as it is, cos ka derivative you have got minus sine log x. According to chain rule, derivative of log x 1 by x upon x upon x. Now minus cos of log x, derivative of x is 1 and whole divided by x square and whole to be divided by your x square. In the denominator we have your x square. So that is the final answer, or you can say that is the second derivative. Second derivative. Now we are supposed to simplify a little bit, because this is the x and bracket minus sine log x upon x. It has no denominator. Whole is x square. So it is better first of all take the LCM in the numerator. As I take the LCM x of the numerator, so then what will be, I will be having, if I take the L in the numerator, the LCM, that is your x, or it comes to be minus x sine of log x, or minus x cos of log x, sine of log x minus x cos, this x goes to here, or one of the x square is there, that gets multiplied with this one and we get x cube. Here we get obtain, what is being obtained here, it is we get here x cube. So this is our what is called second order derivative of the question number 10. Now in the numerator we can take the minus x also common. Still little bit of further simplification if you want. Let us take up minus x common, and the end answer comes to be sine log of x minus cos of log x, and divided by x cube, or this one of the x get cancelled, and we get denominator way we will be getting, that is your, what we will be getting in the denominator, may we will be getting x square. This one of the x get cancelled here, and we would obtain, that is x square. So that is the final answer, that is minus sine log x minus cos log x and divided by x square. That is the second order derivative in the question number 10 of exercise 5.7. Now after this, let me see, in case we have some other important question